I usually start lectures by saying, any questions?
What kind of universe are you going to talk about today?
Well, I was listening to you people talking about universes, and it seems to me that there's one possibility that is so simple that people don't discuss it, because certainly a question that occurs in all religions is who created the universe and why, and what's it for. And one thing that preoccupies me a little bit is the question of why do things exist? And I think the answer is that that's an extra hypothesis that doesn't make any sense. You see, it's all right to say, does this class of water exist? But if you ask, does X exist? That means, is X one of the things in the universe? So to say that the universe exists is silly, because it's saying the universe is one of the things in the universe. So there's something wrong with that idea. Well, if you carry that a little further, then it seems to me that it doesn't make any sense to have a predicate like, where did the universe come from, or why does it exist? So another view, which might be related to the famous many worlds theory, is that this is just a possible universe. And there are lots of possible universes, and there isn't any reason to say that this one is distinguished, except that we're in it. So if you think of a computer game or something like that, here's a little sequence of reductions. First, imagine that there's a computer that simulates some little world, and there are people in it, and the people are pretty smart. We'll talk about how they could get smart later. And after a while, one of the people asks the other, why are we in this world, and where did it come from? And of course, they're fooling themselves. There isn't any world. It's just a simulation. Somebody wrote the program. But if they got that far, then they could say, who wrote the program? Okay, now step two is, suppose somebody wrote the program and didn't run it. So there's no computer. Well, still, once you've written a program, and let's say a description of the computer it runs on, then everything that happens in that world is determined, and the computer and the program logically imply what people will be in it and what they'll do and what they'll ask. And so all of a sudden there doesn't have to be a program, it's just a possible computation. And then the next step is you don't even have to think of it. There is such a computation. So anyway, the question is, getting back to our universe, what's going on here? Why is the universe we're in the way it is, whether it exists or not? And now there's this famous thing called the anthropic principle, and some physicists take it seriously, and some think that there's something wrong with it and they shouldn't think that way. But clearly we couldn't ask that question unless our possible program that we're running had certain properties. And one of the properties that you need to have an intelligent creature is that they're, well, we know how we got here in this universe. We evolved. And you can't evolve unless you have self-reproducing machines, or approximately things like something like DNA or RNA in some way to copy it. And there are other constraints on the universe that come from the anthropic principle. You couldn't have a Guth-like universe where suddenly things are exploding and creating stuff. So you can't have too many bubbles. Or, in fact, I think you have to have something like conservation laws, because if energy weren't conserved, then every now and then some configuration would appear and everything would blow up. So the real question is why the universe has to have laws at all, I suppose. But one thing I've noticed is that when physicists try to explain to the public this is the old days before things got sophisticated, they would make a great fuss about how, what they call the uncertainty principle and so forth, and they'd say, you know, the world isn't the way Newton described it, things are probabilistic and indeterminate. And the curious thing is, it seems to me they very rarely mention the opposite side of that. The reason why Pauling was so interested, being a chemist, is that nobody talks about instead of the uncertainty principle, I'd like to call it the certainty principle. If you take a Newtonian solar system, it won't last, or at least if it's a big complicated one. Jerry Sussman and John Wisdom once simulated the outer planets for a while, and they decided they were stable for about at least 3 or 4 billion years, but it looked like the orbit of Pluto was chaotic. They didn't simulate the inner planets, and for all we know, or for all I know, it might be that the influence of Jupiter and Saturn, which are really big, are enough that at some point in that time maybe the Earth will get enough energy to be thrown out into space. But generally in classical physics you can't have things like atoms with things in orbits that stay there a long time. And it's only, so what I'm saying is nobody explains to the children in grade school and high school when they talk about quantum mechanics that in fact quantum theory is why things are so stable and certain. They'll emphasize that if you had a DNA molecule, there's a possibility that one of the carbon atoms will suddenly tunnel out and land in Arcturus. But the fact is that at room temperature, a molecule of DNA is good for several billion years, and that's one of the reasons why evolution is possible. So it's sort of interesting that in communicating with the public, most physicists are so entranced with uncertainty that, I mean, have you ever heard a physicist explain that quantum mechanics is why things don't jump around? It's sort of a funny thing. And I think this question of why the universe is the way it is, if you think of a collection of possible ones, is maybe we should take the anthropic principle more seriously and say, if you're thinking of various models, which of them are stable enough to support the kind of evolution that we know took the order of a billion years. Apparently the first cells appeared pretty quickly after the Earth got cool enough. I think I've heard people estimate that it's less than 100 million years. And then it took about 3 billion years to get to really good cells, that animals and plants appeared about 400 or 500 million years ago, and then things took off very rapidly, but evidently it was a long period where nothing much happened. Anyway, somebody asked, what about intelligence and emotions, and why don't we have, it's a completely different subject, why don't we have good theories of what the mind is and how it works? And I think in the last few years, some people have started to get good theories of the nature of thinking and so forth. Before computer science, there weren't particularly good theories. It seems to me that to understand something like a brain, you have to have hundreds of concepts like data structures and different kinds of memories and so forth. And if you look at psychology, it seems to me it has a very strange history. There are a few thinkers like Aristotle who sort of start out with some pretty good and pretty bad ideas about psychology, and then, as far as I know, nothing happens. The ideas of Aristotle in the book on rhetoric seem to me about as good as the essays by John Locke and Hume and the English philosophers, even Spinoza, so that a couple of thousand years elapsed without any progress in psychology. And although physicists started up around that time with Galileo, and we've had 3 centuries of rapid progress in physics, it seems to me that psychology didn't start till around 1880 or 70. That is the first recognizable idea that the mind is some sort of mechanistic system, and you can make theories and try to predict them and do experiments to confirm it, is barely a century old. And even that stuff didn't make any progress till around 1950, when we started to see cybernetics in the 40s and artificial intelligence in the 50s and 60s, and something called cognitive science starting to appear in that same period. So a mysterious question is why didn't science have ideas about thinking until recently?